last part is we're going to be multiplying monomials by polynomials, polynomials by polynomials, and we just need to remember one basic idea called the distributive property. And sometimes we might have to use it more than once, and in this case we'll use what I call the double distributive property, because I have to do the distributive property twice. So let's start up here. I have a monomial, one term here, multiplied by a binomial, two terms, that is in parentheses here. So now when I do this multiplication, I need to do the first term, this first thing, times each one separately. So I need to distribute. So here we go. Again, do the numbers first and do letters as they correspond together. -6 times 1. Well, that's -6. A squared times a cubed. Again, add the exponents. A to the 5th. W times W is W squared, adding exponents. Okay, so that's the first part. I've already done that. Now let's do the next one. -6 times, and this is -1, would be a +6. A squared times A is A cubed, adding exponents, and W times W to the 4th is W to the 5th, adding exponents, because that's 1, 1 plus 4 is 5. And here I am at the end. These are not like terms, even though they both have A and W. A is to the 5th here, it's to the 3rd there, so I already can't do it. But also, W squared and W to the 5th there, another reason I can't do it. The powers must be the same also. So this is my answer. 6A to the 5th, W squared plus 6A cubed, W to the 5th. Okay, now we're going to take it a step further. Here I have a binomial, 2 terms, times a trinomial, 3 terms. Okay, now, this is actually the same idea as this, distributive property, except we're going to do it twice. We're going to take, and you could do it either way. You could start with this one or this one, but I always find it easier to start with the smaller of the two, just like up here. And you take each term by itself and distribute it. So here I have W. W is my first term here. I'm going to multiply W by everything in there, like it's the distributive property. When I'm done with that, I'm going to take the next term, 2s, and I'm also going to distribute it. That's why I call this the double distributive. I'm distributing more than once. If there were 3 terms, I would distribute a 3rd time. Just do it with every single term. The method of FOIL, first, outer, inner, last, which doesn't apply in this case, is actually just the double distributive property with a nice name. I'm not going to show you that method right now because if you get this, FOIL is easy. FOIL is the same method with less terms. Okay, so here we go. Distribute the first term. W times W squared is W cubed. W times -2W WS. So I have -2, because this is 1W, 1 times -2. W times W is W squared, and there's an S there. -2WS squared. Now the last one, okay, so 1W times that is going to be 4. And just to keep the order the same, since I have W in front, I'm going to put WS squared, because I had W in front here. Oftentimes you might go in alphabetical order, but in this case, it was ordered W first, so that's what we're going to keep it. Okay, going the other way, starting with this one, going to distribute all those ones. I've already done it with the W, now I'm going to do it with this. 2s times W squared. Okay, so 2 times 1 is 2. And these aren't the same letters. And again, I'm going to keep it in the same order of W first, then S. So W squared S. Then 2s times here is 2 times -2 is -4. Okay. And S times S is S squared, and the W is still a W. And hopefully I don't run out of room here on the screen. 2s times 4s squared, well 2 times 4 is 8, +8, and s times s squared is s cubed. Alright, whew, that's a long list. That is 1, 2, 3, 4, 5, 6 terms, and We are not done, because now we need to simplify. We need to see if there's anything that are like terms. So I just kind of do it in sequential order. So here we go. W cubed. Any other W cubes in here? No, I do not see anything, so I'm going to write W cubed. And whenever I have lists like this, as soon as I write the next thing down, I cross this off so I don't forget about it later or miss something later. I know that I've taken care of it. You don't have to do this, but I find it a very helpful method. Okay, so minus 2 W squared S. Is there any other place where I have a W squared S? And as I look, WS squared, that's not the same. Oh, W squared S. So minus 2 W squared S plus 2 W squared S. Minus 2 plus 2 is 0. These actually cancel each other out. I don't even have to write anything. They're gone. Minus 2 plus 2 is 0. It's gone. Okay, now looking here, next term, WS squared. Let's see if there's another one. Oh, there is, WS squared. And look, plus 4 minus 4. Well, that's 0. So those cancel each other out as well. Now, this doesn't always happen. They're not always going to cancel out. In this case, it's real nice that it does. And what am I left with? Oh, I have an 8s cubed here. Well, there's nothing to cancel that out, so plus 8s cubed. And this entire thing, after I multiplied it out, became something smaller, which isn't usual, but it can happen because things just happen to cancel out along the way. Okay, so once again, distributive property, double distributive property. You're going to have to do it twice. It is possible to do triple, quadruple, have to do the distributive property. Definitely more than that. The most you'll probably see in this course is 3 if you see it at all.